Hello and welcome to a beginner's course on astronomy and astrophysics. This is your course instructor Mr. Shayok Chakraborty. Let's begin with the course. So in our chapter 1, we will start with the basic concept of astronomy and astrophysics. So first, let us know what is astrophysics. So astrophysics is a branch of space science that applies the laws of physics and chemistry to explain the birth, life, and death of the stars, planets, galaxies, nebula, and other objects in the universe as well. It has two sibling sciences, astronomy and cosmology. So now let's move to them also. What is the difference between astrophysics, astronomy, and cosmology? So the differences are very simple. Astronomy actually measures the positions, luminosities, motions, and other characteristics of any celestial objects, whereas astrophysics creates the physical theories of small to medium sized structures in the universe. Remember, small to medium sized structures in the universe, whereas cosmology does these for the largest structures, that is for the entire universe as a whole, or like the galaxies, or like other, like these largest structures in the universes. So astronomy, what we learned here is that astronomy actually measures the positions, luminosities, motions, and other things. Astrophysics creates theories for small to medium sized celestial objects, and cosmology makes this theory for large celestial objects and also for the universe as a whole. So from here we can say that cosmology can be treated as the mother branch, whereas astronomy and astrophysics are their sub branch. This can be treated like this way. So now we need to know about the latitude and the longitude. So as we all know, our earth is basically a sphere. Though it's not exactly a sphere, but for the sake of simplicity, we actually take earth as a spherical shape. So now this latitude and the longitude are the coordinate system by means of which the position or location of any place on the Earth's surface can be determined and described. So now let's do some elaboration on this definition. So just try to imagine a sphere, and now try to imagine if we start drawing some circles on the surface of the sphere, starting from west to east. If we draw the circle on the sphere, we will see that the biggest circle we will get is near at the center of the sphere. And now if we move towards the north or south, that is towards the upwards or the downward side of the sphere, the radii of those circles will gradually decrease. Now these circles, these are actually called the latitudes, where the biggest circle, which is at near the center of the earth, is called the equator or the 0 degrees, where every position, every other circles are actually denoted by how much southern or northern are those from that equator actually. So now if we move to the North Pole, there actually we will get the latitude to be 90° north, and at the South Pole the latitude will be 90° south. So this way, similarly, this is something of latitude. Now let's move to the longitude. So now let's try to draw the spheres, no sorry, draw the circles once again, starting from north to the south, and there also we will see a number of circles, but this time the radii of the circles will be same for each of them. So now we will assume one circle to be the 0 degree, and that is called the meridian actually, and as our the prime meridian actually. So from our sake of simplicity, all the scientists over the globe, they have drawn this prime meridian over the Greenwich town of the London, and all the other points are actually eastern or western with respect to this prime meridian kind of thing. So now if I tell you that the latitude of any point is 20° north and 80° east, so that means you have to move by 20° from the equator to the north, and then you have to start from the meridian at east 80° and you have to go to east 80° actually. So by this way you can actually reach to any latitude or longitude. So now one example how this thing actually works. When you search for any location on the Google map for navigation actually, so that navigation system actually denotes the latitude and the longitude of that corresponding position of that corresponding location actually, and then guide you through the path. So here we learned about latitude, longitude, equator and prime meridian. So in this image you can see the all these things. So red colored things are equator and prime meridians respectively. So now let's know what is a zenith and what is a nadir. So the zenith and nadir are basically two imaginary points. So first let's start with the zenith. So zenith is basically an imaginary point directly above a particular location on the imaginary celestial sphere. Now what is celestial sphere? We will learn about the next slides in the next slides. Now here the term above actually means the vertical opposite direction to the gravity direction. That is the vertical opposite direction to the center of the earth. Suppose you are standing on the surface of this on the earth. Now if you look towards upwards, completely upwards, above your head that is, and that point which is at exactly above your head on the celestial sphere, that point is called the zenith. Similarly, if you look downward towards the center of the earth, and if we try to look just what is beside the other surface of the earth, as you know, if we just take an example of Kolkata, the completely opposite side, at the completely opposite side of the earth, we have a Mexico. So if someone standing at Mexico and he tries to look at the zenith, so that zenith for that person on Mexico will be the nadir from the person standing on Kolkata. So zenith and nadir are completely opposite to each other, and always remember they are nothing but imaginary points. So for the sake of simplicity, from the sake of simplicity of finding any like celestial object's position, we need to know about this zenith and the nadir. Now let's know what is geocentric and heliocentric approach. So these two are the kind of approaches used in astrophysics actually. So first, the geocentric, as you know, the geo means earth. So geocentric is basically a concept of observing the universe, keeping the earth fixed in the middle, and the other objects, the other things on the universe are actually moving around the earth. So this is just a model. This is something scientists use for the sake of simplicity, for the sake of the simplicity of their calculations in regarding some issues. So this is not the actual scenario. Geocentric is something where earth is kept fixed at the center of the universe and the other things are actually moving around the earth. So now let's move to heliocentric. Helio, the terms helio actually means sun. So heliocentric means the system where the sun is assumed to be fixed and all the other objects are actually moving around the sun. So these are the basic two approaches that all the scientists use in order to study the astrophysics or astronomy or cosmology, whatever you say. Celestial sphere. Celestial sphere is an abstract sphere having arbitrarily large radius and concentric to the Earth. All the celestial objects like stars and other things and other constellations as well appear as being projected on the inner surface of that celestial sphere. So this is basically an imaginary or an abstract sphere. So now there are some other things related to this celestial sphere as well. So first we need to know about the terrestrial poles and or the magnetic poles. So the terrestrial poles are absolutely at plus minus 90 degrees north and south, connecting the line between the terrestrial poles called spin axis of the earth. So the North Pole and South Pole are called actually the magnetic North Pole and the magnetic South Pole near about, although they are not exactly the same, but near about, those two poles are called the terrestrial poles of the Earth. And those 2 points, that plus 90 degree, that is the 90-degree north and the 90-degree south, if we connect those points with an imaginary line, that line segment is called the spin axis of the Earth. Now the projection of those two, now the projection of this north pole on the celestial sphere is called north celestial pole, and the projection of the south pole, south terrestrial pole, on the celestial sphere is called south celestial poles. Now these latitudes and longitudes are also being projected on these imaginary sphere. Now the projection of this latitude is called right assassination, and the projection of the longitude on this sphere is called the declination. So by this way actually, we can actually find that at which point a particular star is at in our night sky. Is the projection of the Earth's orbit in the celestial sphere. Or in other words, it is the imaginary line on the celestial sphere that makes the annual birth of the sun. So now if we try to think that our night sky or our sky is basically a screen of projection like a cinema hall. So, and the things, the sun and all the other objects are being projected, as we all know from the past definition of celestial sphere, from the past slide actually. So from there, if we try to connect that thing, that sun is actually moving on that celestial sphere. So now the total path of the sun on the sphere is called the ecliptic. Now it has a certain angle. The elliptical path is has some angle with the celestial equator actually, because our Earth is making at an angle 66.5 degree with itself. So because of that, the ecliptic path basically, or the ecliptic, has a certain angle with the celestial equator. So now we can justify the equinoxes and the solstices from this ecliptic. So as we all know, the equinoxes are the times when the length of day and night in both northern and southern hemisphere are the same. So at that time, the sun's radiation is perpendicular to the equator. Actually, that is the 0-degree latitude. So now there are two equinoxes. One is the vernal equinox that is said to be occur on the March 20th, and the other is autumnal equinox that's said to be occur on 23rd September. And now there are the solstices. So one is called the summer solstice, and it is said to be occurred on 23rd June, and at that time the day length on the northern hemisphere is maximum. Similarly, the winter solstice, which said to be happened on 22nd December, at that time the day length on the southern hemisphere is said to be maximum. In astronomy, since our universe is huge and it is totally bigger than even our imagination. So we cannot even imagine how big actually our universe is and how much small we are actually on this universe. We are nothing in respect to the universe actually. So in order to study the universe and basically the distances between the objects actually, we need to know some big units of distance actually. So the first of such distance is astronomical unit. So this astronomical unit is defined as the mean distance between the centers of the earth and the sun. Why mean distance? Because the path of earth around the sun is basically a elliptical path, and sun is at the center, at the focus of that ellipse. From Kepler's first law we know this very clearly. And so the distance between earth and sun is not constant throughout the year. That is why the scientists take a mean distance between the earth and the sun, and that particular distance is defined as 1 astronomical unit, and 1 astronomical unit is equal to 1.5 times 10 to the power 11 meters. Now light years. So as we all know, light years is the distance that light can travel in 1 year. Now the speed of light in vacuum, we all know, is 3 into 10 to the power 8 meters per second. And students has some misunderstanding with these light years. Some of them actually they think this is unit of time since it has years in it in the term. But no, light years is basically the unit of distance. Now, parsec is said to be the biggest unit of distance, and 1 parsec is said to be 3.26 light years. Now you can imagine the path a light can take in 3.26 light years. It is beyond our imagination, something like that. So these are the three basically astronomical units that we actually use in studying the astrophysics. So we are almost done with the chapter 1 of our course. Now there are some things that you can try to find out yourself. So first, try to find out the relation between parsec and meters. This is simple calculation. You know the relation between meters and light years. You can calculate that, and you know the relation between light years and parsec. So from that, merge those two and try to figure out the relation between parsec and meters. Next, try to calculate the mean distance between Earth and Sun in light years. So I have already given you the mean distance in astronomical units, and you know the astronomical units to meter conversion. And from the previous do yourself thing, you can find the relation between meters and parsec. So from there you can actually relate light years with the astronomical units, that is the mean distance between the sun and the earth. And the last thing, search on internet for the distance between sun and the Andromeda galaxy. So the name of this galaxy sounds to be something new to you, but don't worry, in our other chapters where we have something to discuss regarding galaxies as well, there we will know in details about these Andromeda galaxies. So that is all for the chapter 1. For the next class we will start with the chapter 2.